So a big part of ensuring a product's actually going to make it through on the road is the testing process. So here at Wedgetail, 50 years has taught us that a product properly tested will make the distance. Often we'll find that products not built in Australia by designers who aren't in Australia don't understand how bad our roads actually are. So we put our racks through fairly rigorous testing to make sure that they're going to make the distance and be able to fulfill the customer's requirements. This vehicle behind me, the Ford F-150, has been one of the most difficult vehicles we've ever introduced a roof rack for. The reason for that is it has an aluminium body. This vehicle has no factory points, no access to the rear of the bulkhead, and can't accept a rivet because it's an aluminium body. We were stumped. How on earth do we fit a rack to this vehicle that's strong enough for Australian conditions? We went to the drawing board, we came up with this clamp system. So it uses clamps over the door mount along with the usual wedge wing that we would normally do. In Australia, there is no design rule relating to roof racks, there's only a standard. And that's the test we're performing behind me, is to ensure this roof rack passes to Australian standard 1235. In a nutshell, what that involves is you take the roof rack, you load it to the stated capacity or the capacity we would like it to pass at. In this case, we're testing to 150 kilograms. And then we do a series of pull tests to ensure that it can stay on the roof, essentially. We have a simple setup with a load cell. So a load cell measures force, and that's displayed on this readout here. And then what we're going to do is we're going to pull forward to 4G, so fairly complicated calculation involved, but 4G for 150 kilograms in this situation is probably around 650 kilograms we're going to pull forwards. Now, in order for this roof rack to pass, we've got to pull 650 kilograms forward, leave it for 5 minutes, and this roof rack cannot move. If it moves, it's a fail. If it stays where it is, it's a pass. Same goes for the corner test, so we'll turn it to 45 degrees to the vehicle. That simulates cornering. Once again, it can't move. And then finally, you have the upward pull test. So we'll do a similar thing upwards. And what we're looking for is for a stable number on this load cell. If you see a number, say it starts off at 650 kilograms, and it starts to drop, we know something's bending or stretching, and that's a fail. So we must not have any dropping in our number. Rather complicated, but that's what tells us it's suitable for the vehicle and it's going to work in a real life situation. So in the case of this test, I pulled it up to 320 kilograms, which is about half of what we need to successfully pass what we want to pass it to. It's already dropped to 313. So what that tells me is something's moving. Is it the brakes? Is it moving forward? Is the vehicle moving forward? Or is indeed the rack moving? In this case, what we'll do is we'll wait 5 minutes and see if it stops moving. If it doesn't, we've got a big problem. If it does, I'll reload it, take it back up to 300, see if it stays. If it continues to keep dropping, I know my rack is moving. The other way I can do it is get a dial indicator up here and see if it's moving. So we completed the test. We had a fail. In fact, something's still moving. We've identified that the car's not moving, the rack's definitely moving. Now it comes down to why. Why has this particular rack not passed our test, our safety check? When we had a closer look at it, we found that this clamping mechanism was sliding on the roof. People say you shouldn't show your failures. This has been a failure. It's disappointing for our design team. We've put hundreds of hours into this product to get to where it is, and it's failed. If we didn't do this test, it'd be on the market with problems. So that's why this test is so important. What we'll do now is we'll go back to the drawing board, we'll draw from our experience and say, what can we add to this product to stop it failing? And then we'll do this process again and again and again until we are more than happy that it's sufficient for market and our conditions. And one of the things involved in making it suitable for our conditions is a margin of error. A lot of people ask us how we can achieve 100% off-road rated. Because of our confidence and our experience, we test it 2-3 times higher than we need to then achieve a rating much lower for the market. In this case, it's failed at that higher rating. So what do? Do we drop the rating and put a red tape around it? No. We go back to the drawing board and make it pass. If it can't pass, we don't sell it. Simple as that.
So this is the concept of what you've done so far. So the problem is, what you're saying is we're sliding forwards under pressure.
Yeah. There was a slight bit of give on a extreme pull test. So we feel that it needs a combination. It still needs a mechanical device, as in a rivet, a nut cert, or something similar.
What worries me is if fitters don't install it correctly, if they don't put the tape on right or the tape breaks down, this is essentially a defective fitment.
So what we've come up with now is like a clever style washer. So the clip comes down like so, and then comes under the cowl like this, and then goes up here and like this, and it has the 3 holes for our sandwich plate that we've designed that sits in front here like this. And then it has a portion that goes through a slot here. This stops it lifting up and holds the rail down in the gutter when it clamps up. Here, where it goes in the door cowl, what we designed is a slot like so the clip can come off, and then the washer is shaped like so, and the rivet goes in here and goes through there like this. So it sits over the front of there, and the rivet sits in the middle, and you can still pull the clip on and off. And then we'll supply rubber tape in here for the surface, to protect the surface of the body.
Lewis, have you got any issues folding those clips? Is the machinery out for it?
Nah, the machine will be fine.
Good. I'm happy with that. Is everyone else happy?
Yep.
Now, as we discussed in the design meeting, our biggest issue was that the rack was sliding because of the lack of tension on the clamps. Now, an obvious fix to that is to rivet the clamp to the body in the opening here. What's not ideal about that is you can't take the rack off if you need to. So what we've come up with is this collet design that allows the clip to be pulled off and the collet to stay behind. That way you're not removing a rivet out of the body every time you take the roof rack off. So here, you loosen the clamp, the clip slides off and leaves the collet behind. If the customer was ever to sell the vehicle, they just drill the rivet out, replace the rivet with a new one, and it'd be very neat to sell the vehicle. We've avoided putting rivets in the top structure of the car. The rivet's not actually structurally holding the rack on, it's just assisting with the sliding motion on this vehicle, and you can't see any hole, like it's tidy. That way, we've been able to achieve our 100 kilo off-road rating. And these are the little things where we go the extra mile to ensure that the fitment is suited to an off-road situation, and we can confidently maintain that 100% off-road rating in the off-road environment.